So let's graph some quadratic equations, shall we? We're in chapter 10 now. Graph y equals ax squared plus bx plus c. This is a quadratic equation. The reason I know this is a quadratic equation is because the x term is squared. That's what makes it quadratic. And this is what the graph of a quadratic looks like. And just to emphasize it, I wrote it up top. All quadratic graphs are parabolas. So this shape here is called a parabola. And this dotted line you see on this xy axis is the graph of this equation, y equals x squared minus 2x minus 8. So how did I get from looking at this equation here to drawing this shape here? This is the equation for this particular graph of this parabola. And how do I get from here to here? Well, there's a few ways to do it. And I'm going to look at it. For one, let's see. I got x squared minus 2x minus 8. And what I think I'm going to do here is, now there's different ways to do it and there's different approaches. But just to show how this and this match, I'm going to find the zeros. And that's what we were doing all through chapter 9, taking that x squared minus 2x minus 8 and setting it equal to 0. So this is when y is 0. Here's the y-axis. Here's the x-axis. When y is not 2, not negative 2, not negative 4, but 0. When y is 0, what does x equal? Well, here it's 0, 0. Here it's 0. It's 2, 0 over 2 up 2. And over here, well, I can see that's when my parabola's crossing there and there. 2 spots. So let's do what we did previously and factor this. So let's see, I've got x there and x there. Factors of 8 that subtract to 2, 4 and 2. Minus 4 plus 2. Negative 4 times positive 2 is negative 8. Negative 4 plus 2 is negative 2. Set x minus 4 equal to 0. And x plus 2 equal to 0. And I get x equals 4. So x is 4, x is negative 2. And those are these spots. Here's 4. X is 4, it's on my graph and there. So my parabola is crossing the x-axis at these 2 points, at these. That's why it's called the zeros or the roots. It's where it's hitting those 2 points. And splitting this parabola right down the middle is something called the axis of symmetry. And that splits it right down the middle, and this is the axis of symmetry. So, what about this axis of symmetry? We'll notice that this is a pretty important part of it. The axis of symmetry, it's sort of a imaginary line. It wasn't graphed there before. But what the axis of symmetry does is it hits my parabola right down here at the very bottom of my parabola, which has a name called the vertex. And the vertex is where the axis of symmetry and the parabola hit each other. So they hit each other at the vertex. And let's see, it's always like the very bottom, a minimum point, or the very top. If it's the other way, it's a maximum point. So where is this vertex? Well, where did it split? Halfway, because this splits it even, halfway between negative 2 and 4 is 1. This is the point 1. This line has the equation x equals 1. That is my axis of symmetry. And this point, this vertex, is at 1, comma, well, when x is 1, I got to find y. And how do I do that? Plug 1 in for x. let's see. Y equals 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8. Y is 1 minus 2, negative 1, negative 9. When x is 1, y is negative 9. That is the point on the vertex here, negative 9. So I got these 2 points up here where it crosses my x-axis. I got this vertex down there. And what I do to draw it is a nice, well, it's already drawn, so it's easy for this one, a nice symmetrical parabola that hits all those points. I could get some other points here, like what if x was 2? What would y be? Here's where a good old t-chart comes in. I already know that when x is negative 2, y is 0. That when x is 4, y is 0. I know that when x is 1, y is negative 9. Those are some pretty key points, the roots there, the vertex. But let me find some other points, maybe along here. How about when x is 0? 0 squared minus 2 times 0 minus 8. 0 minus 8, y is negative 8. 0, that's on my graph. How about, well, I already know 1. How about when x is, I know when it's negative, how about when x is positive 2? Y equals 2 squared minus 2 times 2 minus 8. 4 minus 4 minus 8. When x is 2, y is negative 8 again. I get a double. 2, negative 8, right there. These are on my graph as well. The shape is always a parabola. The more points you put in, the better your shape is going to get. All right, see these letters up here? A, B, and C. Those letters are important. The reason it's in this standard form is there because those A, B's, and C's really give us a lot of information about our graph. Let's take a look at this one here. Y equals 2x squared minus 11x plus 12. And when I look at this, I can see that A equals 2. B equals negative 11, and C equals 12. And this is going to be a parabola. Parabolas have an axis of symmetry. If I can find that axis of symmetry, first, I'm going to be able to graph this a little bit easier. Sure, I could factor it, find the zeros. I'm going to do that. But the thing is, the axis of symmetry is a line, x equals some number, right? It's a vertical line, x equals some number. So x equals any number, that's going to be the equation of a vertical line, x equals. So the axis of symmetry is x equals, and here's your first big step in graphing these. X equals negative b over 2a. Kind of a big deal. X equals negative b over 2a. So that's going to give me the axis of symmetry of this parabola. Let's find it. X equals negative. What's b? B is negative 11. So negative 11 divided by 2 times a. And what's a? A is 2. So the axis of symmetry for this one is negative, and a negative makes it positive, 11 over 4. Let me see if I get a decimal for that. Let me see if I get a good decimal. Divided by 4 is 2.75. 2.75. That is my axis of symmetry. 1, 2, right about there. x equals 2.75. So there's my axis of symmetry. So I'm going to have a parabola that kind of looks like this one up here. It's going to be cutting through that axis of symmetry. I'm going to graph it, and it would help if I can get the vertex. We'll see how up top here the axis of symmetry was at x equals 1. And when I put 1 in for x, I get a value for y, right? X is 1. Well, x is your input. Your input at 1. In this case, I'll put a negative. My output was -9. Let me input 2.75 in for x here, and let's see what we get, all right? Because the vertex is at the point -b over 2a. That's the x value, right? X equals y. So let's find out what that is. -b over 2a, I already says 2.75. So 2 times 2.75 squared minus 11 times 2.75 plus 12. And wouldn't a calculator be nice here? Let's see. 2 times 2.75 squared minus 11 times 2.75 plus 12, enter, negative 3.125. See, the numbers aren't always going to be that clear. That's why we use these. The factoring doesn't always come out really clean. So negative 3.125, let's see. -1, -2, -3, right there. My vertex is at 2.75, -3.125. There is my vertex. Let me find some other points for this. Well, I can find the zeros if I factor it. Okay. Factor to find zeros. 2x squared minus 11x plus 12 equals 0. Let's see, 2 times 12, that's 24. Factors of 24 that add up to 11. Let's see, 3 and 8, right? 3 plus 8 is 24. So 2x squared minus 3x minus 8x plus 12 equals 0. Factor by grouping. I split the middle. Greatest common factor of this first one is x, so x outside of 2x minus 3. And I'm going to factor out a -4. -4 outside of 2x minus 3 equals 0. So 2x minus 3, my common binomial, times x minus 4 equals 0. And I'll set each equal to 0. So add 3, divide by 2, x equals 3 over 2. Add 4, x equals 4. These are my zeros. 3 over 2, that's 1.5, right there. And 4, 1, 2, 3, 4, right there. And I've got a parabola. I know it's going to be a parabola, not like a V. It's going to be that U shape. And another thing I know about it, and I'll get to it in a second, is that the y-intercept is up here at 12. Because when x is 0, 0 minus 0 plus y is 12. Not the best graph, but that's what that one looks like. So that's it. That's really everything you need to know about graphing a parabola. I got to be honest with you. There's a couple little tricks for finding the zeros and the intercepts, like when they don't factor cleanly. But things to watch out for is that parabolas don't always cross the x-axis, but they'll always have a vertex. For example, if I've got a parabola that looks like this, it doesn't have to cross the x-axis. But still, here's my vertex, and it's at what we call a minimum because it's the very bottom of the parabola. Maybe I have something like this. There's a parabola. It's not crossing the x-axis, but it does have a vertex. They both have an axis of symmetry. This is the vertex. And in this case, it's at a maximum, the very top. Now, how do you know when it's going to be opening up like this and have a minimum or opening down like this? Well, I told you. These ABCs give us a lot of information. And to know if it's opening up, then this means that my value for A is greater than 0. And if it's opening down, my value for A is less than 0. So let's graph this one just like we did the one before by finding the vertex and the axis of symmetry and the vertex, and we'll see how it's going to work out. All right. So first things first, I want to identify values for A, which is -2, value for B, which is 6, and the value for C, which is -5. And already I know a couple things. This is negative, so it has a maximum, meaning it's going to open down when I graph it. And another thing I know is this C is the y-intercept. It's going to cross my axis. I already have a point on my parabola. This is the one, because when x is 0, y is going to be -5. So let's see. Not that I have to plot it now, but I know that's the y-intercept. 1, 2, 3, 4, 5. It's going to cross right there at -5. Cool. I already have a point. It's going to open down. So let's first find that axis of symmetry, rather than write it all out. AOS. Axis of symmetry is the line x equals -b over 2a. So in this case, it's negative, b is 6, over 2, and a is -2. So that's -6 over -4. Negative by negative is a positive, and 6 over 4 reduces to 3 over 2. Right, so my axis of symmetry is over here at 3 over 2, which is what, 1.5. So let's do this right here at 1.5. Boom. There is my axis of symmetry. X equals 3 over 2. And let's see. Let me find the vertex as well. So the vertex is the point -b over 2a. Why? Well, I already know that -b over 2a equals 3 over 2. So I'm going to put that into this equation here. Calculators, ho. All right. -2 times, well, 3 over 2 is 1.5, so I'll put it in as decimal, 1.5 squared plus 6 times 1.5 minus 5, -0.5. -0.5. So over there and right here is my vertex. 3 over 2, comma, -1/2. And now you say to yourself, well, it's going to open down. This is not going to cross my x-axis. This thing opens down. And I know it hits this point here. And since it's symmetrical, this is the axis of symmetry, then if it's going to hit this point, it has to hit the point that's equally distant the other way, which is, well, let's see. That's 1.5, so right there. These 2 points are the same distance away, and really that's pretty good. Let's just try another point. Well, you know what? I don't even have to at this point. I've got some key points there. But if I wanted a couple more points, I could try, let's see, what about when x is 1? Let's see, -2 plus 6 is 4, and -5 negative. So -1, -1, that's on my graph right there. Let's see, how about 3? That's enough. That's going to give me a good graph there. I've got my axis of symmetry. I've got my vertex. I got my y-intercept here at -5. I get this point, which is at 1, 2, 3, -5. That's enough points. One more point about this graph is that if I did try and find the zeros, the intercepts here, look at what would happen. Let's say I've got that -2x squared plus 6x minus 5 equals 0. And I wanted to factor this to find the zeros. Well, it doesn't have any, because watch, -2 times 5. Actually, let me factor out a negative so I can factor it. Negative outside of 2x squared minus 6x plus 5. 2 times 5 is 10. Factors of 10 that add up to 6, 1 and 10, nope, 2 and 5. It doesn't have any. It's prime. I can't factor it. So it can't factor it. So I can't find any zeros that way. And that's what happened if I would try. I can't factor it. But just because you can't factor it doesn't mean it doesn't cross the x-axis. All right? I can't factor this, try as I might. X, but factors of 1 that subtract to 4, well, 1 only has the factors 1 and 1, so I can't factor this. But it doesn't mean it doesn't cross the x-axis. So let's go back to the way we were graphing it a moment ago. Right? A is 1, B is -4, C equals -1. This is positive, all right? It has a minimum. It's going to open up. This is the y-intercept, -1. It will cross at -1. So I know a couple things already, but let's just find that axis of symmetry to start. Axis of symmetry is x equals -b over 2a. Let's see, so negative. B is -4, right? That negative stays. It's -4, just negative, right there. Boom, negative. Negative what? Well, if B is -4, okay, -4 over 2, and A is 1. So -4 is positive. 4 divided by 2 is 2. My axis of symmetry is at x equals 2. All right, 1, 2, right here. X equals 2. That is my axis of symmetry. Let's find the vertex. The vertex is at the point -b over 2a, because it's got to be on this line, so the x-coordinate is going to be, 2 in this case, -b over 2a, which is the axis of symmetry, comma y. So I already know that -b over 2a was 2. Let's figure out what y is. Y equals 2 squared minus 4 times 2 minus 1. 4 minus 8 minus 1. 4 minus -4. Negative minus 1, -5. So my vertex is right here at 2, -5. 1, 2, 3, 4, 5. Right there. And if I'm going to plot a couple of points on this, what I want to do is, all right, use a t-chart, right? There's a teacher, all right? X values close to axis of symmetry. The axis of symmetry is at 2. What's close to it? How about 1? When x is 1, because when I know when x is 2, y is -5. How about when x is 1? All right, let's see. Y equals 1 squared minus 4 times 1 minus 1, 1 minus 4 minus 1. -3, -4. Y equals -4. That's on my graph. 1, 1, 2, 3, right there. How about when x is, well, I know when it's 2, it's -5. What about when x is 3? 1, 2, 3. Well, I bet it's also going to be -4 because it should be symmetrical. Y equals 3 squared minus 4 times 3 minus 1. 9 minus 12 minus 1. 9 minus 12 is -3 minus 1, -4. Over 3, 1, 2, 3 down, 1, 2, 3, 4, right? The point, 3, -4. Let's go a little bit wider, okay? How about when there's 3? How about when x is 4? Now, this is going exponentially. At some point, it's going to be, if I put in 5, it might be way off my graph, but maybe when I put 4. Let's see. Y equals 4 squared minus 4 times 4 minus 1. 4 squared, 16 minus 16 minus 1. 4, -1 is on my graph. 1, 2, 3, 4, -1. How about 0? Well, if you were paying attention, when x is 0, that's the y-intercept -1, right? When x is 0, y equals 0 squared minus 4 times 0 minus 1. 0 minus 0 minus 1. That's the y-intercept anyway. 0, -1. That's plenty of points. Look, and it's already filling in my parabola. I can already imagine a parabola going in there. I'm going to try and draw a nice, neat one. Going through the points I have. Okay, I failed drawing a nice, neat one. But even so, that's it. That's how you graph parabolas. Your turn.